All right. Hey guys. Today I just thought that since my project for class was done, that I would try and find something new in the examples to try out, and then maybe find something neat to maybe kind of replicate or see what kind of good stuff was on open processing. Um, but that's what I kind of wanted to do today. So let me know if you have any questions or any comments or anything like that. So thanks. Let's get started. Okay, so in processing, there's a tab where you can click and see examples, and these can be like all of the examples in processing. This is where I learned how to do and use shapes for my class, and this was the sketch that showed that, and they pretty much kind of outline like, oh, um, this is this is what a pie chart would look like with shapes or something, and they kind of give you a good like variety of what you can kind of do with everything. And so I thought it'd be kind of fun to just try and find something new to work with and see what we could do with it and come out with it. And you can run them to try them out too, like how I just did. These definitely work and show the examples that they created. This one's pretty cool. Hmm, sounds interesting. Ooh, ooh, that's neat. And I love how they have these comment blocks too, because it gives really good explanation for um, what each example does. Let's see. Camera is pretty interesting. Hmm, brightness. Oh, that's neat. Kind of wish you could go back with it too. Oh, it is changing from lighter to darker. Oh, it's fading. Oh, no. I thought it was fading to black. I wonder how they're doing this. Int which bar equals mouse x over bar width. Interesting. I wonder what wave gradient is. Oh, that's neat. It's a shocker to the eyes. But it's amazing what you can do with processing and what you can create. Ooh. Oh, is this? I feel like this could be one of these optical illusions. Is it moving for you, kinda? It's making my eyes move. What's control? Data. We allow a program to decide to take one action if the answer to a question is true, or to do another action if the answer is false. If the variable I is equal to 0, then draw a line. If else statements. Oh, I feel like those are moving for me too. Embedding four structures allows repetition in 2 dimensions. Ooh. So how we know how for loop creates a pattern in processing. A nested one can create a structure for in 2 dimensions. That might be an interesting one to try. Okay, that one up. Iteration. Drawing the gray bars. Just a bunch of for loops. Check out form. Ooh, oh, didn't know. Interesting. It's neat how it does that. Let's see. The first 2 parameters for the Bezier function. Specify the first point in the curve, and the last two parameters specify the last point. Middle parameters set the control points that define the shape of the curve. First 2 points specify the first point of the curve. Middle two set the control points, and the last two define the last point. Interesting. I wonder how they get it. Probably mouse X makes it move with the mouse. Hmm. 3D printers. Ooh. I thought this one was pretty interesting, so how about we go ahead and try it. Nope, that's not what I wanted. Here we go. Okay. Let's kind of just do this for right now and see what we can mess around with. Okay. Let's see if we can make this an ellipse, maybe. Let's see if that'll work. Ooh. Let's see what the box method does for us, if there's any other methods like that, any other functions. Just box to get the size, and then sphere detail. Doesn't really look like that there's more of those kinds of commands, but there could be, definitely could be. Why don't we try messing with let's see it as having fun with examples. And then let's change the size of the box. So 43. Oh, it's a teeny tiny box. Let's change the size of the sphere. Let's not have it that big. Let's try 50. Oh, it's super teeny tiny. Oh, let's kick it up back to 100. That's better. Let's try 150. Getting better with more detail. $100. That's really neat. Then let's try 400. Just for kicks. Ooh, that's really big. Ooh, let's try and make it envelope the box. Oh, it did. That's kind of neat. Makes it seem like we're on the inside. Let's find more examples. Regular polygon. Polygon function created for this example is capable of drawing any regular polygon. Let's let this run. Ooh, triangle. Octagon, hexagon, dodecagon. Try placing different numbers into the polygon function that calls within draw to explore. Polygon function. Let's see. Let's do 10, 10, 100, and then 15. Let's see what that does. Oh, made triangle into polygon. Let's see down here. Let's go with 5, 5, 24, and then 2. See what that does. Oh my goodness. It's kind of cool though. Last one. All the same number. Oh, it's moving. Oh, how? Let's change that to 5, see what happens. Ooh, okay. Oh, maybe that's the actual sides. Look how many sides the shapes have. Let's go with 3. Let me see if it turns into a triangle. Oh, cool. So the last parameter turns whatever the polygon is, and that's how many sides it has. Let's see if this worked. No, not yet. So Oh, let's do 10. Like, let's do, make it look like a dodecahedron. I wonder what makes it go so slow. Let's change this last variable. Actually, let's change it back to a triangle since we know that's how many sides it will have. And then let's change this coordinate here to like 20. Okay, so I think that's the size of it too. So that's parameter is the is how many sides it has, and the third parameter is how big it is. We'll leave that comment there to note for next time. Let's see what this one does if I change it to 10. Maybe that one is the size, is how large the rotation is. Let's see. Go with 100. Yeah, I think that's what it is. Let's leave a comment for here. The second parameter is on the side, well, is how big it rotates. The circumference of that. And let's see. I think the first one may be the speed. Let's kick it up to 100. Let's try 1. Or maybe it's at a constant speed. Let's see. Let's go with 200. Let's see what that does. Oh no. The first one is how big it rotates. Okay, because that's why it's going off screen. Let's see. The second parameter is how the first one. First parameter is how big it rotates. What about, okay, let's reel that one in. So let's try making that one 10 to happens. Let's give it a crazy, outrageous number. Oh my goodness. I think it's also something that has to do with rotation, but maybe how like high it goes in relation to the y-axis. Let's try 90. So maybe it goes like 90 pixels high and only 50 wide. So that probably is the x and y coordinates of how big it rotates and how tall it rotates, if that makes sense. The third one, we thought It was how big the object is. Let's change it to 70. There we go. And then the fourth one, where'd it go? I thought we had a fourth one. Oh, I guess not. I thought we wrote it down. Where the fourth one is. Let's try and figure that one out again. Oh, the number of sides. Okay. The fourth parameter is the number of sides. Cool. Let's save that. Example. Cool. All right. I kind of want to move on. Let's try that. Ooh, this is interesting. Maybe the star one is the same way with the parameters and the shape size. Maybe if I change this first one, it'll be like a 4-star shape. Oh, cool. Let's see. Let's go with 6. That's neat. Maybe this changes the speed of it. Like, let's say 150. Oh, yep, that one speeds it up, I think. Okay. This one speeds it up. Let's go faster. Ooh. Ooh, let's try and make the circle one go really fast. Let's try 15. Oh, wow. Oh, because I changed the shape of it. My bad, not the speed. Just kidding. Ooh, that's kind of neat with all the spikes on it. Let's get it going into a blue again. Too fast now. Let's go with it at 100. There we go. Let's change this. Oh, you can go negative numbers. Okay. Probably rotate them counterclockwise, maybe. Let's change that to 500. Ooh, it's barely moving. Okay, so it definitely affects the speed. Let's change that to 15. Okay, that's pretty cool. Let's see, what else is there? Oh, ooh, neat. Hmm. Ooh, lights. Move the mouse to change the direction of the light. Directional light comes from one direction and it's stronger when hitting a surface squarely and weaker if it hits at a gentle angle. After hitting a surface, a directional light scatters in all directions. Ooh, that's cool. Also slightly creepy, but cool. It's rolling his eyes at you. Okay. Hmm. What else? What else? Mixture. Ooh, wow. Ooh. That's a neat one. How do they do that though? Orange point on the right. Point light. Let's see what happens when I do this. Point light. Oh, it's going green. Oh, that's right, because they have it nicely commented for us. And that part, those parameters say color, and these last ones say the position. Let's change that to 22. Or, there we go. think it only goes to the top when you move it from X to Y, because you don't really see it well left to right. Okay. Let's change the blues color. And then let's go with 155 instead. I guess that's really cool. Almost looks underwater, like an underwater scene. Let's change these numbers around real fast, see what happens. Ooh. That's cool. Darkness, out of darkness. In the danger zone. Out of the danger zone. Let's change that to 2. Let's see what that happens. Ooh, that sounds interesting. That could be a neat element to incorporate in my process of sketches. Objects. Structure. A loop. Oh. Alright. Understandable, I guess. Ah. Ooh, transform. Oh, I remember this one. That's cool. It's cute. Hello, viewers. Oh, he was trying to do the wave earlier. That's really neat. Hmm. Let's see. Rotate, push, pop. Ooh, that's neat. This is stuff that's really neat in processing. Ooh, it makes it bulky. Guys, check this out. This is really cool. Twist it all around. Isn't that like awesome looking? My gosh. What else? Particles? Oh my gosh. Hot mouse, that's so cool. And it could be like it's moving too. Okay, now I'm just playing. Couch. Oh my goodness, that is cool. Oh wow. Sweet boils? That's really neat. But also looks kind of creepy at the same time. Wiggling. That's cool. Yellowtail. I remember this one. That's neat. Yeah. Poor square. I also wanted to show you before we stop open processing. I think it's a really great website. Um, you can find all kinds of examples on it and get really good inspiration. There's a lot of really good people. Like I can show you this one guy I really like on here. He does really great stuff. Isn't that so neat? I love it a lot. But I know you can search for lots of examples and inspiration here in the processing, and the processing software itself does give good explanation and examples to what you can really do with processing, because there's just so much you can do, and you know the examples are just little bits and pieces, and I think when we put them all together it can be like a really good piece of work. This one's my favorite from this guy, this little squid guy. He's really cute. See, and you can feed him by clicking on the screen, and he'll go and he'll move with the mouse. But you can also do things like this too, and sometimes it doesn't even take that much code, like maybe 2 lines of code, and you can do something like really cool. All it just takes is just looking for what you want to do and seeing the examples in code that you can try and do that. And he has a cat generator too. You can change the eyes and the color of the cat. The slider also changes too. And the color of the eyes and the ears. But like I said, there's a lot you can do with processing, and I kind of hope you enjoyed just me messing around and looking at the examples, and hopefully if you've taken like ideas from this, or you've gotten to you didn't know that there was an examples for processing. So really hope you enjoyed the hangout today.